Hello, everyone, and welcome to today's SANS webcast, How to Threat Hunt and Encrypted Network Traffic, sponsored by Corelight. My name is Carol Auth of SANS. Today's featured speakers are Aaron Soto, Director of Learning at Corelight, and Matt Bromiley, SANS Certified Instructor. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to John Gamble of Corelight, who will be moderating today's webcast.
Thanks, Carol. I'm John Gamble here, Director of Product Marketing at Corelight, and as Carol mentioned, I'll be moderating today's webcast. You can ask questions using your control panel, and we'll try to answer them at the end if we have time. If we go to the next slide, I'll just introduce today's speakers. So we've got two great speakers who I have the pleasure of knowing personally. Matt Bromiley, SANS Instructor Extraordinaire. He teaches courses across a range of disciplines from incident response to threat hunting to digital forensics. And he's also a practitioner. He's out there in the field a lot as an IR consultant, meeting with companies around the world to help them with forensics, log analytics, incident response, and hunting. Aaron Soto is here at Corelight. He's the Director of Learning at Corelight, and he's teaching the users, the market, our customers about Zeek and how to use and maximize open source Zeek in their environments. And most recently, he's been a part of the Metasploit development team. He was part of DEF CON's OpenSOC Blue team, Capture the Flag event, and he's coached students on both defensive and offensive techniques. And I can say firsthand, these guys are great at teaching. I've certainly learned a lot from them, and I expect to learn even more today. Don't hesitate to leverage their knowledge and ask questions during this webcast. These guys know what they're talking about. If we could go to the next slide. Just to quickly level set everyone on the call, we don't want to presume familiarity necessarily with open source Zeek before we jump into the heart of today's discussion. So I just kind of wanted to baseline everyone's understanding on this call of what it is we're talking about. So open source Zeek, formerly called Bro, which is what you might be familiar with, is an open source network security monitoring tool. It deploys out of band, so it's passive. It hangs off of a tap or a span port or a packet broker, and it does three things really well. It transforms raw traffic into rich logs, files, and custom insights. It actually has a scripting language on top of it. And it also does a really great job parsing encrypted traffic. So it generates encrypted traffic logs around SSL traffic and SSH traffic, et cetera. Corelight, we are a commercial entity. We were founded by Zeek's inventor and creators, and we make enterprise-grade Zeek sensors. We make them across cloud, virtual, and physical formats. Whatever environment you need, we have an enterprise-grade sensor ready for that environment. And on top of Zeek, we basically make it faster to deploy, higher performance, easier to manage, enterprise grade in short, but we also expand its capability set and go beyond its core security capabilities. And that's actually going to be the discussion topic of today, which is where Aaron is going to spend a lot of time talking about some of the ways that Corelight extends Zeek's encrypted traffic insight capabilities and how you can use them in your hunt. So with that, I'm going to turn it over to you, Aaron.
I'm not hearing Aaron. Is it just me?
Yeah, I'm not hearing Aaron either. One moment.
Okay, sorry about that. I'm not sure why that was an issue, but I apologize. You hear me now?
Sure can.
Perfect.
Yes.
Sorry about that. So to kind of jump in here, thank you, John. If you've watched some of our previous webcasts, you might have seen us talk a lot about threat hunting, some about encrypted traffic, and a great deal about using Zeek data to analyze both. So, and not to pick on Matt here, he's absolutely covered this in webcasts and a lot of the talks that some of us have done together. But you might see, for example, using tools like Iodine to tunnel DNS traffic and identifying that in things like our DNS log. You might have heard Matt talk about in some of the previous talks about analyzing malware binaries and pulling file hashes by extracting files out of live network traffic and analyzing those against open source tools. We talked about non-standard ports, malware that uses, for example, port 443 to bypass detections in things like IDSs and firewalls. or to circumvent host-based detections, or maybe attackers that use very rapidly set up infrastructure with rotating TLS certificates, but still Matt can find them using things like JA3 and JA3S fingerprinting. And these are all incredibly valuable techniques, especially as part of an incident response or a threat hunting scenario. So you might ask yourself, well, what's new, what's different, what's changed this time? And that's kind of what we'd like to talk about here. This is an expansion upon some of those previous webcasts. So if those are interesting concepts to you, I encourage you to go back and review those. But we're in here to dive a little bit deeper. So what's different is what we're calling Corelight V18. Has been a major release, a lot of changes that have come as part of that release. And we're going to talk about a very small subset of those, but some that I'm very excited about, what we're calling the encrypted traffic collection. And this is a group of Zeek-related packages that are focused on a handful of protocols that as a network forensic person, you might be forgiven into thinking that, oh, well, it's encrypted traffic, I can't really get much out of it. So we'll talk about three in particular: the SSH Insights, or as we might call it, the SSH Inference package, which is focused on identifying activity within SSH traffic. I'll talk very briefly about the certificate hygiene functionality that we've added, which is focused on pulling information out of X509 certificates, predominantly within TLS, but of course we see that in a lot of other protocols. And then we'll wrap up with a list of protocols, kind of some examples that aren't focused on an individual protocol, but instead are talking about anomalies that we see within any protocol, looking at a very high level, doing some statistical analysis. So all of these are part of our Corelight V18 release that you'll see if you're a Corelight customer. There's been a lot of changes in the UI, several changes to new logs and additional functionality in some of our existing logs, and we'll get into that a fair amount. But this is all something that we've included to our existing customers, and I'm very excited to talk through this. So looking at a high level, the encrypted traffic collection would break down into three pieces. We have the SSH Insight functionality, and as you might expect, SSH is used commonly by system administrators for day-to-day tasks. It's also potentially used by attackers, and so we'll see a number of detections there that help us draw the distinction between the two. We'll also talk about certificate hygiene very briefly, and in that we will see the use of certificates inside of our network and be able to identify potential concerns. We're going to cover that very briefly, and then we'll focus on the encryption detection piece and talk about some of the statistical analysis there. But let me start off focusing on SSH. So if we think about SSH visibility today, you might be forgiven into thinking, well, SSH is inherently an encrypted protocol, and there's very little we can get out of it. And as of today, that might be understandable. Recognize that there are a few identifiers that are absolutely useful. So, for example, as part of the initial SSH handshake, you'll see version strings that are sent between client and server. So I will have potentially operating system or the client software and version information available. I also get some of the encryption and compression parameters, the algorithms that are being used. But beyond that, there's not a lot in the initial handshake. That does give us the ability for things like hash, HASSH, to very similar to the functionality that we see in JA3, to analyze those parameters and analyze some of the cipher and compression suites to fingerprint specific implementations of SSH. So as a quick example of that, this is existing functionality that you'll see in Zeek logs, or if you're looking with open source Zeek or some of the Corelight version 17, you're already familiar with the client field that you'll see, that clear text string that indicates, in this case here, that I'm using the SSH command on an Ubuntu box. You also see the algorithms being used from both the client and the server side. So the top is the client, the bottom is the server. And then similar to JA3 and JA3S, we can MD5 those strings to get a signature of those tools, be them on the client or the server side. And then also we get for free the host key for those of you who, when you first connect over SSH and you get the warning that says, hey, verify the host key. that this is the machine that you're expecting to see, we get that as well. So these are all tools that we're used to, but doesn't really tell us what's going on inside that SSH connection. So I can see that handshake information. I might be able to fingerprint the client and the server software. I might be able to even go so far as to identify specific hosts if IP addresses are moving around or if there's port forwarding involved, but I don't know what's going on once the connection's established. And so that's where the SSH Inference package comes in. This is, has been a research project on behalf of our Corelight research team, looking at SSH handshakes, looking at the flow of traffic, looking at timing and packet sizes, and using all of those in statistical analysis to identify what potentially is going on, to infer what is going on inside that SSH session. And so as we talk through this, we're going to divide this into two segments, one being focused on everyday SSH traffic, which is to say traffic that you might see in your environment if your administrators use SSH on a regular basis. And then we'll turn to more malicious SSH traffic. These are attacks that you'll some commonly see and some that are much more targeted. This has all been part of research that we've been conducting as part of our what we call our Polaris program. This is where we partner with customers to help them and help all of our customers build these insights such that they can be applied to enterprise scale traffic. So let's dig in. Let's talk about what that looks like as we think about everyday traffic, as we think about how I might use SSH as part of my daily tasks as a system administrator. Let's divide that into two categories. Let's talk about interactive traffic, and that would be where I have an SSH client. I connect to an IP address and port, authenticate as a user, and then I'm manually running commands to type a command and then review the output and type another command and interactively work with that server. So that's one use case. The second being an automated use of SSH. And this is where we have potentially scheduled tasks or other tool sets that rely on SSH for communication. And in those instances, we're not talking about a user so much in control of that session, as much as it would be a tool or a framework or some other larger infrastructure that's using SSH. And so as we look inside either of those cases, you might see file transfers, you might see things like SCP sending files up and down from the remote system. From the interactive side, you might see users manually typing in commands and reviewing output, more sporadic output. So let's see what that looks like. If we fire up an elk stack, we point our Corelight sensor at it, and we start looking at some of the data in Kibana here, you'll notice just visually a very regular pattern that's emerging with this particular data set. So as we see here, it looks like every minute with very high granularity, we have a job that's potentially kicking off and generating some SSH traffic, presumably something automated. There's probably not a user doing this every 60 seconds. This is probably a tool or a cron job or a scheduled task. So we have these regular connections between these two hosts. These are inside the network, the local addresses in this particular case. And so we have this 147 originator, that being the client in this side, and the 108 responder, that being the server that's being SSH'd into. We have the auth attempts and auth success fields. So these indicate that there was a single authentication attempt, in other words, one entry of a password or a key, and that it was successful, so that this particular host was able to connect to that machine correctly. So all of this, these first 5 columns are ones that if you're familiar with Bro or Zeek or an existing Corelight user, you're probably pretty comfortable with these. What you are not going to have seen before is this new functionality in V18, and that's our inferences column. So this inferences column is going to give us some insights as to what that SSH traffic is doing. In this particular case, we have the FD keyword, which is to indicate a file download. And this FD is telling me that in these connections, what we're seeing is the originator, 147, SSHing to a server, to that 108 address, and downloading a file from that server, which is to say we're sending data from 108 to 147, and we can identify that just by looking at that traffic. So this is some of the functionality the SSH inference package gives us. So let's kind of talk about this. Maybe let's have a scenario where I have an AWS jump box. Maybe I have some cloud infrastructure, and I've got the AWS cloud or the Corelight cloud sensor deployed in my AWS environment. And so as an administrator, I'm going to SSH onto a jump box that lets me pivot into my, let's say, production infrastructure. From there, I'm going to pivot to this 108 hosts. I'm going to authenticate, and now I have an SSH session inside this 108, in the context of this 108 machine. So let's say I'm troubleshooting a service and I'm typing in a command and I'm looking at this status file to figure out why I'm having issues with this service here. So my status file tells me, oh, my config isn't found. That's why this is crashing. So let me go ahead and exit out here, type my exit command, drop back to my jump box. And fortunately, or perhaps unfortunately, if this is a production environment, I have a script that'll go ahead and get me back online. So I've got this configuration script here that is going to SCP to that 108 machine. Is going to use key-based authentication in this particular scenario. So I have a key file that I'm going to use to authenticate to that box, and I'm going to take this config file locally, and I'm going to upload it to that 108 machine, that server that I need to get back online. So when I execute this command here, you see it returns immediately. So that's been kicked off, and let's hope that does the trick. But what does that look like if we look at the data? If we go to our Corelight Cloud Sensor, we're pulling that data off, and let's turn back to Kibana and see what that looks like. So to start off with, we have a noticeable spike in the traffic here. We see that we have a burst in SSH activity, and this SSH activity indicates that there might be something worth looking at. So let's go ahead and click and zoom in on that time area, that 30-second time span.
Hey, Aaron.
Hey, please go ahead.
Hey, really quick. So first off, welcome everyone who's joining here. Some of you who may be watching, may be thinking some of the same things I'm thinking. Can you just give us like a really quick, like 10-second, 15-second background? Is this all in Kibana? Like, how is all this data getting inside of here?
Right. So in this particular example, we have a cloud sensor deployed. So this is part of the our AWS, let's say, production infrastructure that I want to monitor all my SSH traffic going in and out of. And of course, it's monitoring all of that traffic. But in this case, we're kind of zooming in on SSH. And so that Corelight sensor is forwarding traffic to my Elk Stack, my Elasticsearch engine, and that's being rendered here as we see in Kibana.
So these are Zeek logs.
Correct. Well, so there's a small distinction here in that those first 5 columns are what we see in the open source Zeek package, but a lot of times I get the question of, well, what differentiates Corelight? And that's really what we're seeing in that 6th column, that inferences column.
Gotcha.
This is the new functionality here. So there's a small, subtle distinction there worth noting.
Perfect. Thank you.
Sure thing. So as we look at this particular session, as I zoom in on that brief time span, we see 3 SSH connections. And so to start off with, we see the file download that we're used to. That was we're familiar with that, but we have these 2 new inferences that we haven't seen before. So let's talk about those briefly. We know that there was keystroke activity, in other words, interactive activity. So that KS tells me that the statistical analysis of that traffic implies that it was interactive, that there were keystrokes sent back and forth between the client and the server, or the originator and the responder, to use the Zeek vocabulary. The second line that you see there is the file upload inference. And so that tells me that there was a file uploaded, as you and I know, that was the config file that was sent through that script. So from that, obviously, this is from an internal IP. This is from a jump box that presumably I know and trust. So from that, that might not be a cause for concern. It's up to you. The tenet of Zeek and Corelight is that we give you that data to decide whether that's something you would expect. Maybe in a production environment, you don't anticipate administrators interactively getting sessions on some of your services, and so that would be a cause for alarm. Maybe, on the other hand, that is something you're used to. But the fact of the matter is now we have the data to make that distinction and act accordingly. So that is the kind of everyday use case. Let's talk about something a little more malicious. Let's talk about if an attacker is using SSH against me, what are the things that I can key off of here, and what are some of the inferences that might help me? So let's break this down. There's a lot to cover, and let's start with scanning, port scanning, version scanning, capability scanning. These are very common attacker techniques, and if you have any externally exposed SSH services, you're seeing these, well, constantly. So the distinction here being something like a port scan, just checking to see if the port is open, for example, just doing a TCP three-way handshake, and this is extremely common. We have version scanning, which is where the scanning tool or the attacker is pulling back version information. So that is identifying some of those version strings that we saw in clear text, and that can be helpful for an attacker who's trying to identify if this particular SSH server has a vulnerability. And then finally, we have capability scanning, and that is where the attacker or the scanning tool is completing the SSH connection insofar as pulling back things like host key information, Cipher Suite supported, and so on. And that can be helpful in pulling out those fingerprints that might be of interest to an attacker. But in these cases, the attacker is stopping just shy of attempting to authenticate. As we move more towards credential-based attacks, now we have an attacker who is trying to guess how to break into our system. So they're using tools that are doing a brute force attack, which is to say, searching through an entire key space or an entire incrementally working their way through passwords to try and break into a host, or guessing credentials from a dictionary file from, let's see, since it's December 2019, let's try winter 2019 and see if maybe I can find any accounts that, newly created accounts that my IT team has a kind of a static password for. And so we get into credential-based attacks. At the high end of the scale, we get into exploits, and this is where an attacker is directly targeting the SSH server and has identified a vulnerability within that server. And we'll talk through a very specific example there with authentication bypasses. But let's start back at scanning. And for those of you who are comfortable with Nmap, you're going to be very familiar with something like a version scan. So this is using the Nmap command, port 22 against an IP address. The -SV is to indicate a version scan. And now this is going to connect to that host on port 22 and pull back that string. And that's what we saw in the Zeek logs, right? That's the string that we can identify in clear text. And the attacker is pulling that out to help identify exactly what version of OpenSSH we're using. So they can potentially go search for CVEs or proof of concept attacks that they might be able to use against that machine. Maybe in this case here, we have an attacker who's a little more focused and is pulling out host key information. So they append this SSH host key script, which, as you'll notice down towards the bottom, is pulling out host keys that are unique to this server to help them fingerprint this particular machine, maybe to identify if this machine has been imaged somewhere, if they are used in maybe some public image, or if those keys have been in any way compromised. So let's look at those two attacks from the data side. And so if I have data here in Kibana, very quickly, just from the visualization, there's a sudden spike, as you might expect, from this burst of activity. And so as before, let's zoom in on that time span. We see our inferences column here has a great deal of new keywords to talk about. And let's start off with the top there, SC. So SC is to indicate that there was a scan, specifically a capabilities scan. In this case, there were a number of connections that are doing the full handshake and pulling out those host key information, those host key details. We have a version scan. So this was that -SV that we saw in Nmap that was pulling back just the version information, stopping shy of pulling back host keys. And we have some port scans as well, which is a much lighter kind of just checking, you might consider it a TCP full connect scan, if you will, for those of you who are more familiar with the Nmap vocabulary. So from this, I have some fairly detailed information that I can identify what this attacker is doing and just how much information they're extracting. But let's go one step further. Let's talk about an attacker who's trying to break in by SSH. And so now we're talking about an attacker who is using maybe a list of credentials, as I mentioned, a brute force attack, incrementing through all possible passwords, or a dictionary attack, where they have a word list that they're trying to guess some common passwords. And this can be, dozens, hundreds, thousands of times.
Have we lost Aaron again?
Yep, I'm not hearing him.
I apologize.
Okay.
Thank you for that.
Aaron, excuse me. If you'd like, you can go ahead and switch to phone call.
Okay, I can keep an eye on it. I see what it's doing here. I
Okay,
apologize.
thanks.
So as we talk about brute force attacks, we're talking about an attacker who's using word lists or dictionary lists to break into a system. We're going to see a lot of authentication attempts, and the attacker is just hoping that the user that there's a user or a service account with a weak password. That's really their hope and their way in. So looking at this from the attacker's perspective, if you've used a tool called similar, or if you use Hydra or a tool similar, this is going to be pretty familiar to you. But in this case, the Hydra tool is trying the root user account in hopes that that has password authentication, and is applying a word list. So in this case, using a Metasploit word list against that same host, against the SSH service. And this is something that is going to take a while. This is something that is going to be automated and used at scale. So in this particular instance here, if we look at our data, we'll see a spike, as you might expect, in SSH activity as we look towards the right side of the graph here. And so that might be a clue, but without that SSH inference functionality, I'm not really going to know what's happening inside there. So let's look down at our inferences column. You'll notice a handful of new keywords here, this BF, which is to indicate brute force. So this is a high level of authentication attempts that are happening inside that SSH session. If I set up in the top left there a Kibana query, a KQL query, focusing on that inferences column, I can look at brute force attacks or anything that's been flagged as an excessive number of authentication attempts. And so quickly, I can narrow down my data set to just these handful of connections here. As you might look for your auth attempts and auth success columns, that's kind of where my eyes dart to, because I want to know if the attacker is successful or not. So we see 5 authentication attempts, which are Ubuntu SSH server by default cuts off the connection after 5 attempts. Critically, I'm looking at that auth success value to identify that there was no successful authentication. The attacker did not actually get that shell on that host. So that gives me maybe a little bit of a sigh of relief in that I know now that the attacker didn't successfully guess a password. Obviously, that's probably my primary concern. So I want to highlight as well that we do have another inference that is BFS, which is to indicate brute force success. So this tells me that the attacker would have successfully guessed a password as well. So I can key off of either that auth success column or the BFS inference. Ever the persistent attacker, we now have perhaps angered someone who has some more specific capabilities. And now we have someone who is targeting a vulnerability within my libSSH server. If you were watching Twitter in October 2018, you might be familiar with this particular vulnerability. This allows an attacker to bypass SSH authentication, this particular CVE. And the way this works is as part of the SSH handshake, just to go into some detail here because there's some appreciation about how this package is identifying the authentication bypass. But as a client in the SSH protocol, it falls to the client to send this request, this auth user request message to say, I'm ready to, or we need to move on to the authentication stage. And there was a vulnerability in libSSH where the client could just say, we've already succeeded. We've already to send what the server would normally send as an auth user success message, which is a pretty cool trick. It allows the attacker to tell the server that they've already authenticated and just bypass this whole step. So as we look through that, let's talk about from the attacker side again. Here's a proof of concept where we are looking at the libSSH auth bypass. So this is a tool widely available online that tests and exploits this particular vulnerability. And in this particular configuration, I have my target IP address and port. Now I want to point out here that as maybe a system administrator, I've decided to hide SSH on port 2222, maybe to mask that that SSH is running and sneak past. But this attacker's found it and is throwing this proof of concept to test if they can run this ID command. So since this is a vulnerability in SSH, they actually have root command execution on this host. So that ID command returns UID 0. In other words, the attacker can successfully run commands as root. So our very excited attacker looks towards the etc shadow file. For those of you from a Linux background, will immediately recognize that as the place that password hashes are stored. This is a place that we can identify password hashes that can be used to authenticate via SSH. But not satisfied with that, they also check to see if there is a authentication key set up in the SSH folder for root. And so as we see from the output, this second command looks to have succeeded. And as we scroll down a little bit more, you might notice that we have our password hash. We might have the beginnings of our SSH private key. Now the attacker doesn't need the exploit to gain access any longer. They can authenticate as this administrator user or as the root user. So definitely some cause for concern, but if you didn't have something like the Inference package, we wouldn't really know what's happening here. So let's take a look at the data and see what we see. As you look off to the right, you'll notice a little spike in activity here. So we have a handful of connections, and as we look down below, we see this external IP address that might stick out to you. So if I'm used to internal SSH activity, this might be something that would be a concern here. Now, that external host looks to have successfully authenticated using my auth success column. And so that could be some cause for concern. But the real concern here is what this new inference is telling me. So this auth bypass inference, ABP, is telling me that that client, that originator, bypassed the authentication step. In other words, Zeek or the Corelight engine was able to identify that this was not the normal flow of SSH traffic. And I want to emphasize here, this is not signature-based. This is not something that's focused on this particular vulnerability or is focused on this particular SSH client server traffic. We're not looking for a particular string or a series of bytes. What we're looking at is the flow of traffic and saying, okay, we should have had an authentication step here and it got skipped. So if somebody creates a new, if Matt decides to write a new proof of concept targeting this vulnerability, or if there's another vulnerability in a similar SSH server, we'll still see that detection. And I think that's a pretty interesting story there.
Hey, Aaron, quick question for you.
Yeah,
as you're walking through these here, actually do me a favor. No, go to the next slide there, because you actually might have beat me to the punch. There we go. So you've made a lot of really, really good references to the inference package and kind of pivoting off of these inferences fields. And maybe you're about to walk over this for our attendees here, but how do I get access to this information? Is it just there now if I'm in Corelight, or what's the availability here?
So if you're an existing Corelight customer, this is something that is integrated in version 18. So we work closely with our customers to help them update and make sure that everything goes smoothly. But if you've got automatic updates configured, congratulations. You have a lot of this functionality now. So you will have this new inference packet, this inference column added to your SSH log. That is fair game, in addition to some of the other things that we'll be talking about shortly. So in short, this is magic. That's our goal, is to bring the power of Zeek to make it as simple as possible. But to emphasize here as well, this is something that is unique to the Corelight appliance. If you are an open source Zeek user, this is not functionality that's part of the open source package. This has been a very concerted effort from the Corelight research team. So we're proud to include this as part of our Corelight sensor. So as Matt mentioned, there's a lot of new keywords here. And as I ran through those use cases, let's kind of just summarize briefly. As a defender or a threat hunter, this gives me a lot of utility. So if I'm doing a threat hunt and I am looking for unexpected user activity, that's to say maybe someone manually SSHing around my production environment, that KS keystroke inference keyword might be of interest to me. If I'm maybe in a development environment or something a little more informal, maybe not. Maybe that's not of interest so much. I have the file upload and file download inference keywords, and so those could, as an attacker, that could indicate that an attacker is staging tools in my environment or extracting data, exfiltrating data to a remote host. Again, maybe these are parts of normal activity. It's to you. This is your data to decide and to make those calls as to what to be concerned about. As we move down our list here on the third bullet, we start talking about port scanning, version scanning, capability scanning. This is clearly a little more malicious, not necessarily something actionable or not necessarily something worthy of a detailed investigation, but that could be helpful. That could be something that gives you a sense of what's going on inside your network or what's externally accessible that you didn't realize. As we continue our way down the list, we get more concerning. We start talking about an attacker who's guessing passwords, trying to break into a particular host. And so now we're talking about brute force attacks, or in the more alarming case, the brute force success keyword that tells me that the attacker was able to guess a password and was able to gain access to a machine. And then at the far end, now we have authentication bypasses, and this is clearly something malicious. This is clearly something that we wouldn't expect to see on a network in any scenario. So there's a lot of functionality here, to be sure. And as I've emphasized, this is something that you want to tailor to what to your environment. This is your data. Do with it as you need. So if you're not familiar with the Corelight appliance, or you haven't seen the latest version 18 release, this might be a little bit new for you. But this is the refined web UI. This is actually a unified interface that if you use our single Corelight appliance, or you use Fleet to manage a whole group of interfaces, or excuse me, a whole group of sensors, this is the new interface that you'll see. So as we on our left there, we go into our sensor configuration on the top nav bar. If we go to packages, you notice we have all these new packages in our encrypted traffic collection, and it's as simple as checking a box, and you've got those new fields accessible to you. It's worth pointing out, as we talk about customization, that you have a quick edit icon that lets you customize these individual detections, or lets you edit the package as a whole. And so the goal is to give you the data and let you build dashboards, let you build detections, let you integrate in with your existing workflows to make this exactly what you need. So that's a lot focused purely on SSH Insights, and that's something that I think we're super proud of. There's a lot of detections there that, especially in the context of a threat hunt, let me get visibility into purely SSH traffic. But that's one subset of the encrypted traffic collection. So very briefly, I'll mention the certificate hygiene functionality, and this is where we're monitoring X509 certificates, be those, for instance, part of a TLS connection, but we're looking through to make sure that certificates are up to date, or that if they're new certificates that we haven't seen before, or certificates aren't validating properly, which is to say they have an invalid certificate chain. There's a lot of useful functionality in there, and I don't want to gloss over it entirely, but in the context of a threat hunt, that's not as applicable for NetOps. There's a strong case to be made. But let's keep the conversation focused to threat hunts. And so for that, I want to go to the third component of the encrypted traffic collection, which is encryption detection. And so we're going to dive in here into a fair amount of detail and talk through a couple of use cases. I'm going to hand it to Matt here, who's done a great deal of research on ransomware, and I think has some fun challenges lined up for us.
Awesome. Thanks, Aaron. And for those of you watching, hopefully your mind is where mine is right now after seeing Aaron just slice and dice SSH traffic like it was nothing. And my mind's just putty. And now he's like, oh, let's talk about ransomware too, because we're not done. So for those of you watching, just to summarize, we're at kind of three high-level types of encrypted traffic detections, or hunting, if you will. The first being obviously the SSH dicing, the second being certificate examination. The third is going to be kind of encrypted protocols right out of the gate. And when we were putting this together and thinking about some of the malware that likely does this, I really wanted to keep the focus on some of the most prolific malware that's out there from a just overall impact perspective. And I really wanted to give Aaron the challenge of, hey man, could we from a network defense perspective start to actually impact some of the most, as I mentioned, prolific, some of the most disruptive and costly malware that's out there? Like, can we actually start to make a dent in this kind of stuff? And I have to start out by just kind of stressing to everyone that over the past couple of years or so, I think without a doubt, it's become pretty evident that ransomware has become a huge problem for enterprises of all sizes. And I can remember a day, and some of you probably remember a day too from an IR perspective, where you'd get a ransomware case or ransomware would come through and you'd be like, yeah, I hope you got backup, so let's move on. But these days, we're talking millions of dollars at a time. These are huge cases. And I got to kind of jog your memory here. Things such as just this year alone, we've had millions of dollars worth of ransoms. And one thing has stayed the same through a lot of these. Now, all of these different breaches that I've got listed here have all had different variants of ransomware. I will say that there are some commonalities. The CyrusOne data centers and the Texas municipality breach, I believe shared the exact same ransomware family. I'm not sure about the others 100%. I know City of Baltimore was like Robinhood for example. But one thing remains the same. And for those of you, and Aaron, let's hop to the next slide. For those of you that have seen me talk about this before, ransomware families change. However, the overall flow of communication tends to stay the same, meaning you have a pretty straightforward approach here. You have a piece of malware that gets installed, it gets dropped on the system in a number of ways: malvertising, email dropping, whatever it may be, spear phishing. Ransomware gets installed. It reaches out to establish that initial connectivity to say, hey, I'm here, grabs an encryption key if it needs to, and then it starts to spread and move laterally and cause all these issues. So I'm going to stand by my original kind of, and we're talking months, not a year ago, that I said, I think this would be a lot easier to detect at the network level. Now, admittedly, we used to do that with certificates, and we used to do that with the JA3 and the JA3Ss that Aaron mentioned at the beginning of this presentation here. That's not going to work for us anymore because we have malware that communicate over custom protocols. They don't even establish a certificate handshake. They simply just start talking. And that really gave us a little bit of a blind spot. But as Aaron mentioned, I threw a challenge out to him to work around this. So the ransomware that we're going to talk about here from a traffic perspective is one called Shade ransomware. Now, I picked on Shade primarily because it's one of these ransomware families that, I don't know, for me tends to kind of hide under the wire because it's been around for 5 or 6 years, almost 6 years now, but I promise you some of you just heard about it for the very first time when I said it. It's been delivered in multiple languages. It's a global ransomware family, but oddly enough, despite being that old, there are some things that have stayed the same as Shade has kind of been passed around the world. The big one here, and I've got it on the next slide as Aaron's going to show us, is actually the desktop background. This has stayed pretty consistent for a long time, and hats off to Unit 42 over at Palo Alto for allowing me to borrow this screenshot and put it in here. But their distribution method has stayed the same, and their communication method has stayed the same. And that's really, for me, one of the biggest takeaways for everyone watching here is some of the things that Aaron's walking through and some of the detections that Corelight are building in are very, very static and predictable changes, meaning your attacker is not going to rewrite their network stack as often as they're going to rewrite their host-based detection. So I think this is where the true advantage lies. But with that said, Aaron, I'll let you go to the next slide, and I'll let you take it from here because I talked ransomware. I'm going to let you talk custom crypto, and then we'll put Corelight to the test from a detection perspective.
Sure, sounds good. So looking at the custom crypto scenario, now we're talking about malware that is focused on using cryptography that isn't trying to mask itself. We're talking about malware that isn't trying to hide itself and mask itself as traffic that we would normally see on our network. And so for that, we'll use Metasploit as an example. So here, if you're familiar with Metasploit using the MSF console, just kind of walk you through very quickly what we'd see from the attacker's perspective. They're going to generate a payload. This is going to be a reverse TCP payload, which is effectively a targeted payload that's going to reach out once it's executed on the remote machine to the attacker's host on port 80. So even though the traffic is on port 80, this is going to be fully encrypted by Metasploit with the goal of bypassing any kind of detections that are on the target network, and with the goal of obfuscating traffic in such a way that it's going to make it very difficult for an incident response team to identify. So the attacker kicks this off, sets up a listener, and waits. And this obviously now is this is where things can get interesting. This is where the attacker might send a spear phishing email. They might I don't know, drop USB thumb drives at the target organization. However they need to get execution on a remote system. There are a multitude of ways that the attacker has available to them at this point. But eventually, if they succeed, they get back a interpreter session, and this is where that target machine is calling out of the network and gives the attacker their initial foothold to dive in. And so these are two very interesting challenges, both one, as Matt was talking about from the ransomware perspective, where it's not even necessarily targeted, as we saw quite a list of organizations that have fallen victim to this. It's more opportunistic. Versus this particular scenario with Metasploit that is clearly targeted, that is clearly an attacker focusing on trying to break into this network. So two similar but also very different challenges to focus on. And so as Matt said, let's talk about how encryption detection plays into this. And so a few things you'll notice as part of version 18 is that we are doing statistical analysis of traffic to identify that which is encrypted and that which is not. And from that, we can get a few tidbits, a few potentially actionable pieces of information. So to start with, we might identify services that, in the first case, are on a port that is usually associated with encryption, but in this case, the traffic is clearly not encrypted. So by doing a statistical analysis of traffic, let's say on port 443, if we identify traffic that we would normally expect to be encrypted beyond that initial handshake, and in this case, let's say we see all clear text, that is something that is worthy of investigation, and we'll raise a notice identifying that as an unencrypted service. In other words, a service that should have been encrypted but was not. And in the second case here, let's talk about services that or connections that start off immediately encrypted without a handshake. And so as you think about things like SSH, things like TLS, really any standard service is going to have a handshake at the beginning. And this is where there's some kind of a structure, some kind of a mechanism, maybe a key exchange, some validation, authentication information, what have you, that you expect to see before statistically the traffic becomes randomized and looks to be encrypted. So these are two very interesting and actionable notice types that we'll see if you're a Corelight customer and your notice log, you'll have these available to you now. So in addition to those two notice types, there's one other thing to mention, and that is a new log called ETC Viz. So that's the Encrypted Traffic Collection Visibility log. And this is where we provide a lot of the internals of that statistical analysis, as well as try to give you the summary. So our goal is to give you that data if you really would like to dive in, but at the same time, to just give you the information that you need to make a decision and act. So focusing on that column in the ETC Viz log, you will see a summary of connections and an identification as to whether they're encrypted or clear text. So to take a moment, if you're familiar with Bro or Zeek or Corelight's history field in the con log, in our connection log, this will be a little more comfortable for you, but if you're not, we'll still walk through it and explain why. So to start with, you'll notice log entries have an uppercase or lowercase. Uppercase to imply that the originator, or as you might say, the client, is this particular state, to say encrypted or clear text. So in that top line, if I see an uppercase E, that tells me that the originator was speaking using encrypted traffic. In the lowercase e, that tells me that the responder, the server, was using encrypted traffic. And so that's something you would expect to see pretty regularly, especially when you're talking about TLS, port 443 connections, your standard use cases. Now you might notice in that column an exclamation mark, so E exclamation. tells me that there was no negotiation. So that exclamation is kind of I don't want to say an alert, but at least something to draw our eye and say, that's odd. This should have been something that we saw a handshake for, that we saw a kind of an initial setup, and we didn't. So that implies that that particular connection was using some kind of custom cryptography, and that could be a piece of malware that already has a key embedded in it. That can be an attacker that's using some encrypted protocol, but is not something standard. Or potentially that could be, I don't want to say benign, but that could be something like an encrypted chat software that has keys embedded in it that is handling. So that's certainly something worth looking at. And then as we work our way down, you'll notice U is to indicate that was something that we expected encryption, but there was none. So for instance, if I'm looking at port 443 and I'm seeing clear text, but you know, obviously I would expect something encrypted. That's worthy of note as well. And then finally, you know, for instance, HTTP traffic, you might just see C to indicate clear text. So this is doing a statistical analysis of that traffic to help identify whether it's encrypted, whether it's clear text, and what we see in that handshake. So as Matt has challenged, let's do some threat hunting here. Let's assume I don't get to know what the attacker is up to, but I'm just looking through Kibana and I'm looking for encrypted traffic on port 80. That might be a hypothesis in your hunt to identify if there is any traffic on port 80 that wasn't clear text. And looking at my Kibana dashboard, sure enough, two things pop to the surface. At the bottom, we have the ransomware, and you'll notice that here we see encrypted traffic, so that EE on port 80. As it turns out, that piece of malware is actually using TLS, as you might see in Wireshark. You might see something that looks expected, a client hello and a server hello. But then as we look to the top row there, that is a Metasploit session. And so in that, Meterpreter is not doing a handshake in both directions. So we see an exclamation mark, which is to tell me that our payload that deployed immediately called out and had an encrypted traffic going each direction without so much as a handshake. Now it's worth pointing out that in that first line, I have a single exclamation mark. You might see variations of malware that have double exclamation marks, which is to say that there's no handshake in either direction. As Matt and I have researched previously, Metasploit actually does have a bit of a negotiation, kind of a key exchange that isn't often talked about as part of the reverse TCP payload. So in this case, our Corelight appliance has identified that there was a brief handshake going from the server to the client, or client to the server, excuse me, but from the server to the client, there was none. So both of these are highly actionable. And the case of seeing malware that doesn't have any kind of handshake and is also using encrypted traffic on port 80, that would be something that we'd get a notice log for. So Matt, what do you think? Is that that pretty decent job there of catching some of these attacks?
I will tell you, Aaron, I'll be honest, with that level of, you know, what's funny, without really much visibility in the way, I think you gave me some really good indicators to start to sort off of. So I'll call it a win in this case. But now I just want to look at the rest of my network and look for all those EE bangs and see what's going on.
For sure, absolutely. So I think there's a lot of really interesting use cases from a threat hunting standpoint for both SSH traffic as well as just any protocol at all. And if that sounds of interest to you, that's something that you want to check out in the encrypted traffic collection. So I'm looking at the clock. I'm noticing we're running a little short on time, so I want to wrap up here and give some time for a few questions. Matt, do you want to kind of take us home here and maybe talk about, kind of wrap things up and maybe give your some context from your perspective?
Yeah, for sure. So I think, you know, and I tend to rely back on my network forensic and incident response perspective, but really from just an enterprise defense perspective, I think, you know, encrypted traffic has just continually been this plague that people don't really want to have to deal with or face, or it becomes an easy out, if you will. It becomes oh yeah, it's encrypted, we're not going to see anything anyways. And as Aaron kind of did a good job of pointing out to us, that's obviously not the case anymore. I think more importantly too is, as network traffic becomes more and more and more encrypted over time, which is certainly happening, we're now in significant double-digit percentages here. These types of analysis techniques are going to develop more, and they're going to become really, really useful for us. So for those of you that, again, are in some of those defensive roles, whatever that capacity may be, I really want you to walk away from this with a couple of takeaways. And the biggest one being, just because it's encrypted does not mean you're lost. There's still lots of features and functionalities. There are some, I'm going to call them older, maybe legacy, because Aaron presented a lot of really good new and unique knowledge for us. But some of the legacy artifacts, if you will, and again, by legacy, I'm saying maybe a few years, like the JA3 and the hash and everything, you've got those to lean on. And now we're starting to understand more and more about what's happening with our packets and what that traffic is telling us. So, I want your environment's encrypted traffic analysis to be just as, if not even more, strong and well built out compared to plain text analysis as well. So just know that, you got some capabilities and functionality there. Aaron, I'll let you talk really quickly about V18's release, and then we might have a few minutes left for some Q&A.
Sure, absolutely. So as we kind of talked about SSH Insights specifically, there's a lot of functionality there for a threat hunter to find anomalies in your user activity, which is to say a user who's interactively gaining access to a machine and transferring data back and forth or running commands, as well as we saw a lot of attack tools, from the benign, things like scanners, through credential guessing, which is a pretty commonplace attack, and into exploit attempts against SSH services themselves. So for SSH traffic, there's a lot of new data in V18 that is relevant to threat hunting. And the second thing that we talked about was the encryption detection, and that is where we're looking through protocols to find things that implement custom cryptography. And these can be tools like payloads, like Matt's ransomware, a lot of common ransomware that implements that, but also looking at ports. And so I know Matt has talked about things like the dynamic port detection, DPD, that identifies protocols no matter what port they're on, and we're doing this analysis no matter what port we see it on. So there's a lot of opportunities there, even for attackers that are being clever, using their own crypto, using ports, specific ports against us, that we can still hunt them down. So I think there's quite a lot of new data here from a threat hunting perspective that's pretty exciting. With that, we have a couple minutes left. John, do we have any questions that would be worth discussing here?
We do. Let's see, we've got a few minutes left, got 4 or 5 questions. Hopefully we can get through most of them. Let's jump in. So we had a question here. It was a question about what's the delta between Corelight and open source Zeek with Encrypted Insights, and what kind of insight can you get out of the default open source framework versus Corelight. So I'll just answer quickly. There's a lot of insight one can get from the open source project without these added insights that Aaron was walking through. We actually did a webcast earlier. I just sent the chat to the whole attendee list. So if you take a look at your chat window, you'll see a link there. That's the prior webcast we did with SANS. Matt was on that webcast with our CEO, Greg. Matt walked through a number of detailed use cases with encrypted threat hunting with just pure open source Zeek logs. So anything to add on top of that, Matt, before I move on to the next question?
No, sir. I was actually going to draw a reference right back to that one, so I think you covered it.
Cool. We've got a couple more questions here. Aaron, this might be a question for you. It's a question around, are you saying it's typical for malicious traffic to have the E!/E! Inference? Do you have stats showing percentages of malicious traffic behaving this way?
That's something that is definitely a focal point of research. I think that especially when we see pieces of malware that are implementing their own crypto and not doing any kind of a handshake, certainly common in the open source framework, as we saw with tools like Metasploit. That is something that's fairly common. As attackers move towards trying to mimic SSL and TLS handshakes, that can get a little bit more interesting. And so for those, a lot of the things, as Matt just mentioned, some of the webcasts that we talked about, the techniques like JA3, are well researched and very good foundations for catching traffic that is using more standard crypto. So I'd like to think that between those two, we've got it covered.
Great. Let's see here. We've got one last question that probably can be answered quickly. If a user mistypes their password 4 times and then gets it right the 5th time, does the inference still show up?
Sure, and this kind of is a not to go on too long, but this is a great tie back to kind of the Corelight philosophy and giving you control of what you decide is malicious or not. So as I mentioned in the web UI, there's some customization that can happen as you can edit individual detections. You can enable or disable notices, but specific to this, you can set thresholds and adjust what you consider worthy of a brute force attack. So if I'm in an interactive environment with a lot of users SSHing to hosts, I might want to turn that up a little bit so that, on Monday morning, when people forget their passwords, it's not going to set off any notices, versus if I'm in a production cloud environment and I'm not expecting to see that traffic, I can turn it down. So to answer your question, that is something that is entirely within the control of our customers.
Excellent. Thanks, Aaron. And with that, we're at time. Thank you, Matt and Aaron, for your time today. We'll call that a wrap. Carol, I'll turn it back over to you.
All right, thank you so much, John, Matt, and Aaron, for your great presentation, and to Corelight for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.